Good morning, everyone. Let me introduce myself first. My name is Shiva Augusta, a computer science student from Dian Nuswantoro University. Today is a very special moment for me as one of the participants of UDINUS 2.0. I feel very proud and excited to be here presenting the project that I have been working on with so much dedication. My project is application of image processing technology in video-based fall detection for safety improvement in healthcare facilities. Sounds technical? Yes. But trust me, it's more than just technology. It's a real step towards making a huge impact on lives, especially for our elder loved one. I believe that all of us here share the same goal, to innovate and create a better world. Therefore, pay attention to this presentation because perhaps this is where we can see how image processing technology can change the safety standard in healthcare facilities. I'm going to take you on an exploration of how I have utilized algorithm, video processing, and a little bit of technological magic to create a system that is both intelligent and beneficial. Let's start it. After I talk about the overview of the project, now I want to explain about the problem. Imagine an elder living alone at home, falling in the middle of the night without anyone knowing. Incidents like this happen all too often. And in fact, falls are one of the leading causes and serious injury and death among the elder. As the elder population grows around the world, the need to protect them becomes even more urgent. However, problem doesn't stop there. Existing monitoring technologies such as motion sensor or alarm are often not reliable enough. Many fail to accurately detect falls, especially if the environment change, such as dim lighting or complex video backgrounds. This system also tends to generate false alarm or worse, fail to respond altogether. This is the core of my problem. How can I create a system that is truly capable of providing efficient, accurate, and real-time safety surveillance for the elder without relying on outdated? After I talk about the problem, now I want to talk about my goals. My aim is to create a video-based fall detection system that uses a bounding box to track movement accurately. The system detects moving objects, enclose them in a box, and analyze change in position to identify falls in real time. This ensures immediate alert providing safety for the elder and peace of mind for their families. Through this project, I hope to show how simple, effective technology can make a big difference in people's lives. After I talk about my goals, now I want to explain about my solution. My system offers an efficient solution for real-time fall detection. The process begins with capturing and processing video to reduce the noise. Moving objects are then detected by comparing frame with the background, and their position are tracked using bounding box. The system calculates the centroid of this object to analyze movement patterns. When a fall is detected based on sudden change in position or acceleration, an alert is instantly triggered. This approach ensures fast, accurate, and reliable monitoring for the elder, particularly those living alone. The solution provides peace of mind for both for elder and for their families, knowing that they are under the supervision of reliable and intelligent technology. After I talk about the solution, now I want to explain about my challenge. This is the challenge I faced during the development process. Developing this system was not without challenge. One major issue was sensitive to change in lighting and complex video background. For example, a brightly lit room during the day can turn dim at night, creating shadows and noise that affect detection accuracy. Another challenge was data noise from sensors, such as a small, irrelevant movement like swaying curtains, which could confuse the system. I also need to ensure that the system could process video frames in milliseconds for real-time detection. Lastly, teaching the system to distinguish between normal movement like bending down and falling required high precision in patterns recognition. This challenge pushed me to innovate continuously, and I believe that overcoming them has strengthened this project. Before I started the implementation, I will explain about why I choose bounding box. I choose bounding box because the bounding box is easier to implement and less sensitive to pixel noise. In addition, the bounding box provides enough representation to track the object as a whole without requiring analysis of the notion of the motion patterns of each pixel, making it more efficient for simple applications such as fall detection in videos. By using bounding box, I ensure that the system remains lightweight and perform well in real-time scenarios. Okay, after we talk about what the reason for using bounding box, now I will explain the implementation. Here is the flow of code implementation for the video-based fall detection system that I developed. This code imports the necessary libraries such as pathlib, numpy, matplotlib, and OpenCV. The variable video path points to the location of the video file to be analyzed. And then iSample frame is the frame number of the sample to be displayed. And then for the crop region relative is the relative area for the video to be cropped. And then the imshow here function is used to display the image with conversion from BGR to RGB color format using matplotlib. Okay, this section opens the video file and retrieve the original dimension, weight, and height of the video. Crop region relative is used to specify the cropping coordinates of the video frames to be processed. The pre-crop function here crops the frame according to the specified area. And then this section, the video is read frame by frame. Each frame is cropped based on the cropping area and stored in the frame list. And then for the display a specific frame, the code display each frame in the list frame and display the sample frame based on the specified iSample frame number. And then for the background estimation, the background is calculated by taking the median of all frames, which then convert to grayscale. This code aims to estimate the background appearance of the video. Okay, and then this section create a binary mask for each frame based on the difference between the frame and the blurred background. The contour of this mask is also calculated, and the bounding box is displayed to detect object movement. And then for this part, this code calculate optical flow using the Farner-Back method to analyze the movement between frames, convert it to HSV format, and convert to BGR format for visualization. In this section, the user select the region of interest to start tracking the object. And for the motion tracking and fall detection, this section uses object tracking to detect motion as well as detecting falls based on the acceleration of the centroid position change to change of the track object. If the acceleration value exceeds the threshold, a fall detection is considered to have occurred. To have occurred. And this is how to show the output. And then now I want to play this video to make it more clear. The program starts by reading the input video that will be used to track the movement of the object. I select the object to be tracked using a bounding box. This object could be a person walking or sitting. The program analyzes the tracking algorithm, which will monitor the position of the object at every frame of the video. And the bounding box starts following the movement of the object in the video. And the blue line indicate the blue line indicate the areas that is being tracked. And the program automatically issues a falling notification on the screen notifying that there was falling incident. And then the program continues to monitor to ensure that the object remains in the frame or recovers from the fall. So this is the demonstration show how the program detect objects, track movement, and detect falls condition with visual alerts. With program can be further developed to improve accuracy. While the system is already efficient, we still face challenges such as lighting change that affect accuracy and data noise from the sensor. To overcome this, the way forward is to integrate the system with IoT device to improve monitoring, enhance the system resistance in various conditions, and develop machine learning algorithm to be more adaptive in recognition complex movement patterns. With this innovation, we believe the system will continue to evolve into a smarter and more reliable safety solution. In conclusion, this research proved that the combination of image processing technique, object tracking with bounding box is able to detect falls efficiently. The developed system make a real contribution in improving the safety of the elder, especially those who live alone. However, further development is still need to address environment challenge such as change in lighting and complex background to make the system more reliable in various conditions. Okay, that's all from me. Thank you for listening, and I appreciate your attention.